Okay, so now into challenge 2. So challenge 2, we're getting one hex string. We're going to decode it into a binary. Get another hex string, decode that into binary, and then when we XOR one against another, we should produce a third hex string. Okay, so let's go straight into it. Alright, so since we're going to be converting hexes into binaries, what we want to do is first of all start off and verbalize that conversion. So I'm going to bring up a case here, and I'm going to copy that string, put that into my decoder. That gives out the binary. Do the same thing with the second string, string 2. And to slap that in here. And that gives the plain text hits the bull's eye, okay? So using these two strings, what I can do is I can start what's called list comprehension, or in this case binary comprehension. So I'm going to say for every binary in string 1 and for every binary in string 2, I'm going to do the binary XOR, which is an Erlang function. I need to bring that in here, of X and Y, of X XOR'd against Y. And see what that gives me? That gives me a really long list of numbers, which some of which may correspond to ASCII numbers, but in any case it's too long. And what's happening here is it's returning every single combination of X with Y, right? X here with Y here, okay? I don't want that. I just want to take the sample that corresponds to the combination of the first X with the first Y in string 2, with the second X in string 1, with the second Y in string 2. Okay. To see how it works, I'm going to do a little experiment here. I'm going to say for A, B, and C, and for Y in X, Y in Z, I'm going to do X and Y, just to see how this works. So as you can see, it gives me every single combination running on AX, BY, and CZ. So if you notice, every fourth element after the first one gives me the sample that I need. So that's what I'm going to do here. I'm going to say, I'm going to take the fourth element after my initial one. So to say that, I'm going to go enum.take every 3 plus 1. Alright, that gives me AX, BY, and CZ. So using that same principle, I'm going to do the same thing with my generated list here. So I'm going to say get my generated list, pipe it through this. Let's take every, and that thing needs to be a string dot length of string 1. Right? In fact, it should be string 1 plus 1. Right? Because if you look at the example above, it was the length of the list put in, which was ABC, which was 3 plus 1. We'll do that. We're going to get string dot length. So yeah, so that gives me the string or the car list in this particular case. That kid don't play. The kid don't play, but that's a car list, not a string. So if you look at the requirement here, we wanted to return the hex string. So I'm going to return the hex string and convert this into a string first of all. So I'm going to go to string, right? And that gives me the string back. And then I'm going to pipe that dude into base.encode 16. And if you look at that, that gives me the right answer here. It gives me that 7, 4 to 9. And here we have the 7, 4 to 9. Okay. So the last step would be to put that result into a function, and just for using the top window here. As you see here, that's what's a function. So we have a string 1 turned into a binary, string 2, which is a binary. We're going to variabilize the string length up here, and then we're going to generate our list here with the 4 and the x and y, do the x and y and x and y. Then we're going to use the rule that you want to sample, take every length of the string plus 1 from the generated list above it, convert it into a string, encode it into hex, and dump out the answer. So just to test that, we're going to say c.cryptopals.access, save that, and run it. I'm just giving myself a function name. Yep, cool. XOR x's. I'm going to pass in these two now. And that gives out the answer. Okay, see you guys for the next challenge. Done.